Let's take a tour through different safety architectures and see how the patterns are combined. We'll start with the simplest architecture, which is the Low SIL single CPU architecture. The pattern name is one channel or one of one, and one of one means there's one CPU there and it has to be working for the system to work. The picture has a Low SIL primary in a solid box. That solid box is its CPU boundary, so we can see that there's a single CPU and it's running either SIL1 or SIL2 software. There's no software isolation within the box, and so this is basically a standard microcontroller running whatever software is in it with nothing special for safety. The pros for this are that it is the simplest pattern, and it's the least expensive hardware because there's nothing special about the hardware. It's suitable for a SIL in which the acceptable failure rate for the system is much more often than the hardware failure rate. And what I mean by that is that if you have a piece of hardware that fails once every million hours, but your SIL says it's okay to fail once every 100,000 hours, then that's okay because the software or other functional failures will dominate the hardware failure rate. The cons are that all the software in the system has to be promoted to the highest SIL present. So if you have a SIL2 system, and even if only one function is SIL2, every line of code in the entire system has to be written at SIL2 so that it won't compromise the single SIL2 function. Beyond that, this system is only acceptable for low criticality SIL1 and 2. And that's because of two things. First, this system fails active. And by failing active, what we mean is when a failure happens, all bets are off as to the system behavior, so it has to be presumed unsafe. And the other thing is, this pattern is only suitable for systems in which the hardware failure rate is much less often than the acceptable failure rate for the system as a whole.